Hello students, welcome to EPG Pathshala. I am Vinodini Kapoor, teaching in the Faculty of Management in Chandigarh, and today we'll discuss about the module Big Data under the paper Management Information Systems. After completing this module, students will be in a position to develop an understanding of what is the concept of big data, various sources of big data, and they shall be in a position to discuss what are different industries that are utilizing big data, how big data is changing information systems, and what are other derived benefits. The amount of data in today's world has been exploding, resulting in what is popularly known as big data. Big data refers to our ability to collect, to analyze the vast amount of data and the ability to harness the ever expanding amount of data in completely transforming our ability to understand the world and everything within it. Big data is a term applied to the data sets whose size is beyond the capability of common software tools to capture, manage, and process. It's not the amount of data that's important, but what the organization does with that data is what actually matters. The size of the data, combined with complexity of analysis and commercial imperative to create value from it, has led to a new class of technologies and tools to tackle it. Organizations are capturing, storing, and analyzing data that has high volume, velocity, and variety and comes from a variety of new sources, which include social media, machines, log files, video, text, image, radio frequency identification, global positioning system. These sources exhaust the capability of traditional relation database management systems and galvanize a host of new technologies, approaches, and platforms. Interestingly, the idea behind the phrase big data is that everything we do in our lives leaves a digital trace or digital data, which is what we can use and analyze. The advances in capturing and analyzing this big data allow us to decode the human DNA in minutes, to find cures for cancer, accurately predicting human behavior in foiling terrorist attacks, pinpointing marketing efforts and preventing diseases, so and much more. It can also be utilized constructively if otherwise it's not secured. The dominant big data technologies in use today commercially are Apache's Hadoop and NoSQL databases. Hadoop is a software framework for data intensively distributed application and has been inspired by Google's MapReduce, a software framework in which an application is broken down into numerous small parts. The concept of big data. Primarily, three major forces that drive the interest and growth in big data can be stated as firstly, enormous growth in the amount of data that is being generated on the internet. Secondly, the evolving strategies of firms to collect data from internal and external sources throughout the product and process life cycle. Thirdly, the phenomenal growth of social media, mobile applications, and sensor based technologies, as well as the internet. All of these forces are generating a flood of data which is increasing in volume, variety, and velocity. Big data is referred to both the type of data being managed as well as the technology used to store and process it. Mostly, the technologies originated from companies such as Google, Amazon, Facebook, and LinkedIn, where they were developed for each company's own use in order to analyze the massive amount of social media data that they were dealing with. Due to the nature of these companies, the emphasis was on low cost, scale, but commodity hardware on open source software. Big data is increasingly being defined by the three V's, which become a reasonable test as to whether a big data approach is the right one to adopt for a new area of analysis. The three V's of big data are: firstly, volume. This refers to the size of the data. With technology, it's limiting to talk about data volume in any absolute sense. Numbers get quickly outdated. Volume refers to a relative sense instead. If the data volume is an order of magnitude or larger than anything previously encountered in your industry, then you probably are dealing with big data. For companies, this might be tens of terabytes. For others, it may be tens of petabytes. It is estimated that Walmart collects more than 2.5 petabytes of data every hour from its customer transactions. A terabyte is 1 quadrillion bytes, or the equivalent of about 20 million filing cabinets worth of text. An exabyte is 1,000 times that amount, or 1 billion gigabytes. Velocity. It is the rate at which data is being received and acted upon. Any delays in execution limit the effectiveness of campaigns, limit interventions, or lead to suboptimal processes. For example, some kind of discount offer to a customer based on their location is very less likely to be successful if they have already walked some distance past the store. Variety. There are two aspects of variety, that is, syntax and semantics. These determine the extent to which data could be reliably structured into a relational database and content exposed for analysis. Modern tools are capable of dealing with data arriving in virtually any syntax. However, they are less able to deal with semantically rich data such as free text. Sources of big data. Let's look at where does the big data come from. As the statistics tell us, most of the big data efforts are currently focused on analyzing internal data to extract insights. Very less organizations are looking at the data outside their firewalls, like the social media. 88% data is transaction related, 73% is the server log data, and say 57% is the data retrieved from emails. Now, these are the internal data sources. Now, taking into account the external data sources, 43% of data extracted from social media, 38% from the audio files, and 34% from the photos or the video files. Big data is often boiled down to a few variety of data generated by machines, by people, and by organizations. With machine-generated data, we refer to data generated from real-time sensors in industrial machinery or vehicles that track user behavior online. Environmental sensors or personal health trackers and many other sense data resources. But human generated data, we refer to the vast amount of social media data, status updates, tweets, photos. With organizational generated data, we refer to more traditional type of data, including transaction information in databases and structured data that is open, stored in data warehouses. As more and more business activities are getting digitized, new sources of information and ever cheaper equipment combine to bring us into a new era, one in which large amounts of digital information exist on virtually any topic of interest to a business. Mobile phones, online shopping, social networks, electronic communication, GPS, and instrumented machinery all produce torrents of data as a byproduct of their ordinary operations. For many years now, data driven companies have been struggling with just what to do with the data that they have collected, but does not fit readily into the relational databases such as the text and the web logs. Big data offers the promise of unlocking the potential of this data and opens up new avenues for value creation with regard to correlation of social network and purchase behavior to form a complete profile of every customer. Big data consists of huge volumes of structured, unstructured, and restructured data from both internal and external sources from which insight and actionable intelligence is sought. Unstructured data. It refers to the data that does not conform to a predefined data model. This implies no relational model and no SQL model. It is mostly anything that we don't store in a relational database management system. Nearly 80 to 90% of all the data in the world is unstructured, and this number is rapidly growing. Examples of unstructured data generated by people includes texts, images, videos, audio, internet searches, and email. The cost and time of the process of acquiring, storing, cleaning, retrieving, and processing unstructured data can add up to quite an investment before we can start reaping values from this process. It can be pretty hard to find tools that people to implement such a process and reap values in the end. Structured data. Each organization has distinct operation practices and business models which result in a variety of data generation platforms. Organizational big data come from commercial transactions, credit cards, government institutions, e-commerce, banking, or stock records, medical records, sensors, transactions, and so on. Almost every event can be potentially digitally stored. Organizations build and apply processes to record and monitor business events of interaction, such as registering a customer, manufacturing a product, or taking an order. These processes collect highly structured data that include transactions, reference tables, and relationships, as well as the metadata that sets its content. Usually, structured data is stored in relational database management systems. Various sources from which big data can be captured. Now, let us look at them. First and foremost, media. It exists in and out of the organization and may connect with the APIs, that is, the application programmable interface, and is moderately structured. Media files such as images, video, audio, flash, live streams, podcasts, etc. The business applications are structured and use APIs that can pull data from both inside and outside your organization. Internally, think that integrating your CRM or your web content management with your e commerce system. Externally, using weather or weather underground data for local personalization is another example. Public web is external, but some very useful applications can be used with it. For example, is your business affected by the daily fluctuation of currency or search term volume that can be pulled from Google Trends? Government, weather, traffic, compliance, healthcare services, and other web services are all examples of public web-based data. Sensor data is high velocity, volume, variety, value when used correctly to understand user context and predict behavior. Sensors go for geolocation, temperature, noise, attention, biometrics to collect reams of data that is used for better purchase and ownership experience in a variety of industries. Examples such as car sensors, traffic recording devices, office buildings, cell towers provide information to be analyzed for various technical aspects. Machine log data. It refers to mobile or third party services that identify, target, and convert visitors. Event logs, server data, application logs, mobile location usage refer to machine log data that can build a repository of information. An interesting diagram reveals the intelligence by variety of where to find and access different sources of big data. We'll now look at social media. It is high velocity, high volume data that can be used to detect trends, analyze sentiment about your brand, customer service, and competitors, or target campaigns to social account that match the email address in your customer file. Social media refers to Twitter, Facebook, LinkedIn, YouTube, Google Plus, that are some examples. Documents can exist inside or outside the organization. They are archived and don't use APIs. Therefore, referring to various Excel, PDF, email, Word, presentation, or plain text files. Okay, students, we'll now take a case. We'll introduce a new coffee product at Starbucks and understand what they try to do with it. Starbucks was introducing a coffee product but was concerned that customers would find its taste too strong. The morning that the coffee was rolled out, Starbucks monitored blogs, Twitter, and niche coffee forum discussion groups to assess what was customers' reactions. By mid-morning, Starbucks discovered that although people liked the taste of the coffee, they thought it was way too expensive. Starbucks lowered the price and by the end of the day, all the negative comments had disappeared. Now compare this fast response with a more traditional approach of waiting for the sales reports to come in, noticing that the sales are disappointing. A next step might run a focus group to discover why. Perhaps in several weeks, Starbucks would have discovered the reason and responded by lowering the prices. Now, let us come to understand who are the actual users of big data. Big data affect organizations across every industry now. Each industry can benefit from the onslaught of information. We look at the banking industry. With large volumes of information that is pouring in from countless sources, banks are faced with finding new and innovative ways to manage big data. While it is imperative to understand customers and ensure their satisfaction, it is equally important to minimize risk and fraud while maintaining regulatory compliance. Big data requires financial institutions to stay abreast with advanced analytics. Education. Now, what could academicians do with big data? They are armed with data driven analytics to make a significant impact on the school systems, students, and curriculums. By analyzing big data, they can identify student performance at various levels and parameters that can segregate students needing more attention, making sure students are making adequate progress, and implement a better system for evaluation and support of teachers and principals. Government. When government agencies are able to harness and apply analytics to their big data, they gain significant ground when it comes to managing utilities, running agencies, dealing with traffic congestion, or preventing crime. But when there are many advantages to big data, governments must also address issues of privacy, data security, and transparency. Healthcare. In healthcare, everything needs to be done very quickly, accurately and in some cases with enough transparency to satisfy stringent industry regulations. High degree of accuracy and timely information available to the medical practitioner is imperative. When big data is managed effectively, healthcare providers can create patient profiles, maintain medical history. Manufacturing can boost quality and output while minimizing waste. Processes that are the key in today's highly competitive market. Manufacturers work in an analytical based culture, which means that they can solve problems faster, minimize wastage of resources, and make more agile business decisions. Retail. Customer relationship building is critical to the retail industry, and the best way to manage is to manage big data. Retailers need to know what is the best way to market customers and manage big data, the most effective way to handle transactions, and the most strategic way in bringing back lapsed businesses. Big data remains at the heart of all of those things. The primary value from big data does not come from the data in the very raw format, but it comes from processing and analysis of it and the insights, products, and services that emerge from the analysis. Changes in big data technologies and management approaches need to be accompanied by similar dramatic shifts in how data supports decisions and product services innovation. Big data is changing the face of information systems. We'll come to reasons as to why big data is changing MIS and corporate information technology. It enables us to move away from the relational database management systems. Now, ever since electronic storage and processing of data began as a centralized corporate function, relational database management systems, it is fundamental to most of the computerized corporate information system. Most of the information systems like ERP and CRM are supported by relational database management systems. NoSQL is designed to capture all the data without categorizing and parsing entry into the system. This shall fundamentally change the architecture of corporate information systems. Secondly, unstructured data handling capability. Capability of handling both the structured and the unstructured data is another very important way of information systems they are going to change. Data variety implies that big data is not just about text or numbers, but it's also the unstructured data. Information systems in future will have to be designed with the capability of handling both these kind of structured and unstructured data. Thirdly, real-time processing. It is the ability to process social media or sensor data as they are being generated and then take necessary action immediately, such as responding to a tweet or Facebook post. Batch processing, nightly or weekly updates, and even near real time data processing are not good enough because the high data velocity is the case with big data. Predictive analytics in memory analytics. If data is being generated in a variety of formats, which can be structured or unstructured, in high volume or at high velocity, the only way that it can be used effectively for decision making is through the use of predictive analysis and in memory data analytics. Information systems in future will have to be designed keeping the same aspect in mind. Most data are either user or machine generated. Most of the big data are either generated by end users, customers like social media data, or by machine sensors that are outside the confines or firewalls of a company. This is unlike in the past when most of the data was generated within the firewall of a corporation, such as transaction data, inventory, or factory production line data, with very little coming from the outside. This will fundamentally transform the architecture of information systems in future. Okay, children, let's understand what exactly organizations are doing with big data and how they are utilizing it. When it comes to using big data for human resources, it can revolutionize the entire industry. Big data raises important questions that need to be asked during the hiring process. How people are recruited, how much talent is being overlooked. Big data is the solution for virtually any HR department. One of the biggest concerns for most companies is their budget. Employers want to ensure that they are making the most of their resources and finding ways to eliminate any extra cost. Employers have used big data for hiring talent who could be the best option for their company. By using big data, employers can analyze applicants to find out which people are more likely to stay with the company once they're hired and who will enjoy their job. Now, this is huge when it comes to reducing employee turnover because employers can almost guarantee finding the right employee for their company. Xerox has been able to cut employee turnover in half after using big data to review job applications. Before this, Xerox relied solely on candidate experience. However, the company soon discovered personality and soft skills are more important during the hiring process. They also found that the more creative hires were likely to stay longer than the analytical type of employees. Let's come to the case of Google, how it has been utilizing big data. Google, as an entire department dedicated to people operations, Google uses big data to recruit and hire the best talent for their company. The team is dedicated to people analytics, which measures whether a candidate is good or bad based on their soft skills, attitude, work ethics, and flexibility. This particular data driven approach has proven a great deal for Google to maximize their hiring efforts and reinvent the human resource industry. Another common way to implement big data into the hiring process is through gamification, which is a great way to improve talent acquisition and management. Through creating a game or a mobile application, you can reward candidates as they complete each step of your hiring process. Job applicants are expected to play these games for 20 minutes, which help the employer determine problem solving skills, creativity, persistence of each candidate. Gamification allows employees to paint a picture of their candidate and determine whether the person has the potential to be a leader or innovator for the organization. Let's now look at what is the benefit derived from capturing big data. First and foremost, it is highly effective in cost reduction. Organizations that have been focused on cost reductions make decisions to adopt big data tools primarily on largely technical and economic criteria. Cost reductions can also be a secondary objective after others that have been achieved. Time reduction from big data, reducing the cycle times for complex and large scale analytical calculations from hours to even days to minutes or seconds. Building customer decision trees. Big data makes it possible for companies to better understand consumers' shopping behavior at each particular stage of the consumer decision journey by analyzing online browsing and searching histories. For example, companies can learn the alternative customers to look at when considering buying a product, the important factors in their final purchasing decision, and how they put together their shopping baskets. Information that can help companies identify valuable upselling and cross selling opportunities. Building customer satisfaction. A common use case for big data revolves around multi channel customer experience management. By analyzing the data flowing from social media sources, companies understand customer sentiment and adapt service delivery across our channels according to offer the best possible customer experience. Okay, children, let's now summarize what we have learned in the module. Big data is a game changing revolution that is fundamentally changing how information is collected, stored, managed, and consumed, thereby transforming the way we work, we live, and we play. The use of big data is becoming a crucial way for leading companies to outperform their peers. Established competitors and new entrants leverage data driven strategies to innovate, to compete, to capture value. Big data will help to create new growth opportunities and entirely new categories of companies like those that aggregate and analyze industry data. Big data technologies are important in providing more accurate analysis, which may lead to more concrete decision making, resulting in greater operational efficiencies, cost reductions, and reduced risk for the business. Large organizations across industries are joining the data economy. They are not keeping traditional analytics and big data separate, but they are combining them to form new synthesis. Thank you.